This is question number 16 of exercise 5.1 from the chapter Continuity and Differentiability. The question is, discuss the continuity of the function f where f is defined by fx is equal to minus 2 if x is less than equal to minus 1, fx is equal to 2x if x is greater than minus 1 and less than equal to 1, and fx is equal to 2 if x is greater than 1. Okay, so you can see that this function given to us is defined for all real numbers. Okay, so we are going to check the continuity of this function for the complete range of the real number. Okay, that is for all real numbers. So the first interval which I take is, or the first case which I take is when x is less than minus 1. Okay, so when x is less than minus 1, fx takes the value equal to minus 2, as you can see. So if we assume that c be any real number less than minus 1, then limit of x tends to c for fx, that is, if we are going to take the limit of x tending to any value c lying in this interval, then this would be equal to limit of x tends to c of minus 2 or simply equal to minus 2, right? And f of c is also equal to minus 2, that is the value of the function at any point c is equal to minus 2. So this implies that the limit of x tends to c for the function fx is equal to f of c is equal to minus 2. Therefore, f is continuous for all x less than minus 1. Okay. Now, moving further, we are going to check the continuity of the function at x is equal to minus 1 because the function changes its value at this point. So, in the second case, I am going to check the continuity of the function when x is equal to minus 1. Okay. So for this I am going to calculate the left hand limit and right hand limit of the function when x tends to minus 1 and the value of the function when x is equal to minus 1 and check whether they are equal or not. So this is the right hand limit of the function when x tends to minus 1, that is the limit of x tends to minus 1 positive of fx, and this would be equal to limit of h tends to 0 of f of minus 1 plus h. This value minus 1 plus h is greater than minus 1. So we are going to take the value of fx as equal to 2x, and this would be equal to limit of h tends to 0 of 2 into minus 1 plus h. When h tends to 0, we are going to apply the limits and we are going to obtain this value as equal to minus 2, because when we are going to place h is equal to 0, this is going to become minus 1 and this is going to be minus 2. And similarly, limit of x tends to minus 1 negative of fx, that is the left hand limit, would be equal to limit of h tends to 0 of f of minus 1 minus h, and this would be equal to limit of h tends to 0 of minus 2 because fx takes the value minus 2 and this value minus 1 minus h lies in the interval when x is less than minus 1. Okay, so this would be equal to minus 2 on applying the limits. So we see that the right hand limit, the left hand limit, and if we calculate the value of f of minus 1, we are still going to get h equal to minus 2. So all these are equal. So this means that the function is continuous at x is equal to 1. Okay. In the third case, we are taking when x is greater than minus 1 and less than 1. Okay. So moving forward, we have been given an interval that fx is equal to 2x if x is greater than minus 1 and less than equal to 1. Okay, so we are not taking the equal value, we are taking the value less than 1. So in this interval, we are going to check whether the fx is continuous or not. So for this, we assume that c be any real number in this interval. Limit of x tends to c for fx would be equal to limit of x tends to c for 2x, and this would be equal to 2c. And f of c is equal to 2c. Therefore, the limit of x tends to c for fx is equal to f of c is equal to 2c. So this shows that the function is continuous for all values of x in the interval, in the open interval minus 1 to 1. Okay. Now in the fourth case, when x is equal to 1, here also at this point x is equal to 1, the function changes its value. So we are going to check the continuity of this function by taking the left hand limit, right hand limit, and the value of the function at x is equal to 1. Okay, so this is the right hand limit of the function when x tends to 1, and limit of x tends to 1 positive of fx can be written as limit of x tends to 0 of f of 1 plus h. Okay, so 1 plus h is a value greater than 1. Okay, so f of 1 plus h would be equal to limit of h tends to 0 of 2. Okay, because for all the values greater than 1, f of x is equal to 2, and this would simply be equal to 2 on applying the limits. Limit of x tends to 1 negative of fx, that is the left hand limit of the function when x tends to 1, would be equal to limit of x tends to 0 of f of 1 minus h, and this would be equal to limit of h tends to 0 of 2 into 1 minus h, and on applying the limits we are again going to get 2, and f of 2 is equal to 2, that is 2 into 1 or 2. Therefore we have limit of x tends to 1 positive of fx, that is the right hand limit, is equal to left hand limit, is equal to the value of the function when x is equal to 1 or all the values are equal to 2. So f is continuous at x is equal to 1. Now case 5, when x is greater than 1, so it is very simple. Limit of x tends to c for fx, where c lies in this interval, would be equal to limit of x tends to c of 2 or simply 2, because for x greater than 1, for any value of x greater than 1, fx is equal to 2, and f of c is equal to 2 again. Therefore limit of x tends to c for fx is equal to f of c is equal to 2. So f is continuous for all x greater than 1. Okay, so f is continuous for all real numbers, which is the required answer. Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.